It's great to be joined today by Julien de Wit, who is a researcher at MIT who is leading the atmospheric study of the Trappist-1 planets, which we spoke about. I guess now it's been a couple of weeks, right, since the big press release about these planets. How long have you been working on this?
I've been working on the Trappist-1 system with Michael Ginon and the Trappist team for now over a year and a half.
And what initially tipped you off to the possibility that these planets could be, well, number one, terrestrial and possibly even Earth-like in terms of habitability, temperature, et cetera? At what point in the process was that something you started exploring?
Well, the terrestrial aspect is something that came first, right? When you look for planets using the transit technique, meaning when you look for this dim of light, when something is passing in front of a star, it tells you about the size of the planet. It gives you what we call the planet-to-star area ratio. So as soon as we could measure the dip, then we knew that they were Earth-sized. So the idea that they could be terrestrial was there in the first place, as soon as they were discovered. Now for their potential habitability, the fact that we know the temperature of the star and how far the planet are told us immediately that they were temperate and hence potentially habitable. So it was quick. Now what is great is that we don't really know, but we'll be able to assess soon.
Let's talk a little bit about the distance of this system from Earth. We've heard the figure 37 to 40 light years thrown around. Of course, light year is a distance, the distance that light can travel in a year. Talk to us about, in practical terms, in a way that maybe will be understandable to the average human mind, how far this is.
Well, it is, to the human mind, it is, it is very difficult to picture. So that I'm not sure we'll be able to help. But what we should do is try to put this in the context of our universe or even of our galaxy. This is really in the neighborhood of our sun. The closest star to us is Proxima Centauri, and Proxima Centauri is 4 light years away. This one, Trappist-1, is about 40 light years away, which is just 10 times further. What matters at this stage really is that it is close. It is relatively close to us, and that it can provide us with this new perspective on terrestrial planets. This may not answer your question, but to bring this a bit further, what's interesting is that this star is one of the star type is one of the most frequent in our galaxy. And so we find that these stars that are small, that can live almost forever, might have lots of terrestrial planets, meaning that what we thought to be, well, the archetype of terrestrial planet like ours, like Venus, like Mars, may not be the actual archetype. Like the stereotypical terrestrial planet might be the planet like the Trappist-1. And it's really nice to have this one at hand, within reach, with future telescopes, so we can study them and hence maybe completely change our perspective on terrestrial planets, habitats on such planets, and life in general.
I'd love to dig into some of the characteristics that you're sort of alluding to here. You have planets that are tightly packed around a star that is cooler than our sun. It's smaller than our sun. Can you talk to us a little bit about what the sort of implications of that are for the planets surrounding this star?
Yes, well, what's interesting is that, so as you said, the star is really small, really cold, actually cold to a point where you even see water in the emission spectra of the star. So that is something that is really exciting by itself. And because this star is so small and so cold, rather than having the planet being far away from it, they are really tightly packed around it, meaning that what we call the habitable zone, which is a concept, which is the place where it is most likely for a planet to be able to have liquid water at its surface, is also very close to its star. And so these planets that are potentially habitable are found very close to one another. So if you were to have life to appear on one of them, it's interesting to wonder how life could exchange or move from one planet to the next, because interplanetary travel on such planet would not last months as it would in the solar system. The planets are so close to another that it would only take days. Now, if you put this back in the perspective of how much exchange there is being between a planet like Mars and the Earth, we can find Martian rocks here because they've been ejected by impact and so on. It'd be interesting to see how much exchange is being of materials and potentially organic material from one planet and the other in such a system. So the idea of a multi-planet biosphere could be something worth investigating as well.
So, and you said that travel between these planets could take just a few days. Is that based on current technology that
Yes.
we have on Earth? Is that how that is considered?
Yes.
Okay. Because of the proximity to the star, a year on some of these planets could last anywhere from, an Earth day and a half to 20 Earth days, so to speak. What about the duration of a day on these planets, which of course is not dependent on the distance from the star, but also the rotation of the planets? Do we know anything about that yet?
So, no, that's an excellent question. That is a funny thing, actually, because a day could just last forever. What we think is that the closest of the planet are likely tidally locked, meaning that they always present the same face to their star, exactly like the moon with the Earth. The moon turns around the Earth in the same amount of time that it turns around itself. So it just always shows the same face to the Earth.
Right.
So it's the same thing for this planet, meaning that they have a permanent day side and a permanent night side. So it also means that if you're standing at any point on the planet, the star will always be at the same position in the sky. So there will be no day per se. There will be no day and night.
And that is
So
for all
they
of
will
the
last
planets that you've identified so far. Every single one has this lack of rotation, so to speak.
We do not know. So they do rotate, but in the same amount of time that they rotate around
Yes,
the star.
yes, you're right. I misspoke.
Yeah, but we don't know. That's something that we'll have to investigate. It is quite likely for the ones that are the closest to the star because of the tidal interaction. For the other ones, this will have to be investigated. But we will know soon. There are lots of question marks that still need to be answered, but all of these are going to be tackled soon.
Okay, whenever we have an announcement like this, very quickly the conversation comes up of could there be some form of life on some of these planets? We don't have that answer yet, of course, but my question is, at our distance, nearly 40 light years away, how can you try to figure out whether there may be some form of life on one of these planets? What are the techniques that are used?
Well, currently, so really, the community is so excited that we have initiated an effort ranging from the X-ray, ultraviolet, down to radio, and this allows us to look at the planet in different ways. In ultraviolet, we're looking for atmospheric escape, exosphere, and so using these wavelengths, but also the infrared, we're able to study the exosphere, the atmosphere of the planet. And so we can search for what we call biosignatures, which are signs of life or sets of gases that could indicate the presence of a biomass. Now in radio, we're looking for signs of magnetic field, but also, I guess you're familiar with the movie Contact with Jodie Foster.
Of course.
We may potentially stumble upon structured radio signal, and we actually corresponding now with SETI's directors. So that might be another way to search for signs of life, more advanced form of life, obviously.
Well, it's absolutely fascinating. These must be exciting days in your lab, right?
It is exciting. I don't know if you've seen yesterday the K2 data, the Kepler Space Telescope provided access to 3 months of continuous observation of the Trappist-1 system, and the whole, a good chunk of our community were just crunching the data at the same time and tweeting about the results over the day. So no, everyone really is on board, and everyone is joining this new venture. It's really a new era for space exploration, and that is exciting. We have 7 beautiful targets in hands, and maybe more to come. So yeah, it is a terrific time for us.
One last thing. I noticed in preparing for the interview that you studied in Liège in Belgium, and the planets are
Yes.
named the Trappist planets, and of course Belgium known for Trappist beers. Is there any connection here in the naming and your background in Belgium, or is this just coincidence?
No, so the link is with Michael Gillon. Michael Gillon, so the PI, principal investigator of Trappist and Speculoos. So the naming goes beyond Trappist because Speculoos, which is the project for which Trappist is a prototype, Speculoos is the name of a typical Belgian biscuits. And Michael worked hard in finding acronyms that would lead to interesting names. And now you have this nice Belgian hint in history
Yeah.
through the discovery of Trappist one. So that is all of this is coming straight from Michael Gillon.
Not a coincidence. Okay, good to know.
Not a coincidence.
We've been speaking with Julien de Wit, researcher at MIT, working on this very exciting project. Thanks so much for talking to us about this.
Thank you.